Welcome to Conversations That Matter. Mike, today we're having another of our conversations with an eminent scientist from Princeton University. Let's talk a little bit about who our guest is today.
Today we'll hear from Freeman Dyson. He's a 91-year-old mathematical physicist, one of the most renowned scientists in the United States, been around for 6 decades.
He's an extraordinary mind. Talking to one of our previous guests who went, you're talking to who? Like, to say that he has a big brain would be an understatement.
That's right, and this is someone who actually works in the same building at Princeton that Einstein worked in. And interestingly enough, not only works in that building, but he was actually there when Einstein was there.
I know, it's extraordinary. You go into the building, there's this bust of Albert Einstein, and the address is 1 Einstein Drive, and it dawns on you that this is a place where some rather extraordinary thinking happens.
Extraordinary, and in his own words, subversive science.
Contrarian.
Contrarian, yeah. Freeman Dyson believes we ought to be using science as a way to upend the apple cart, and particularly teach young people that science can be an act of rebellion, positive rebellion, to push against poverty.
There's many people who are on the climate change side of the equation who are advocating that we're in trouble, and they say that science supports that. They're not going to be so happy with the conversation with Freeman Dyson.
Well, Freeman Dyson is probably someone that comes out on more of the neutral side in terms of climate change. He obviously acknowledges that there's rising carbon in the environment.
And that the temperature has gone up.
The temperature has gone up, but I think his approach is to say we don't know enough, and we need to focus on things in the world that we know enough about to change.
You're right, not knowing enough. He says, well, I know the guy who designed the first computer model that all other models are based on. Like, he knows the guy, and he knows that the model can't mirror what is in climate, and this is his point. And so he says, yes, we've had this effect, but it's the predictive model that is difficult for him to embrace.
That's right, and which is what makes his voice on this issue, particularly as somewhat of a contrarian, even that much more important and pivotal, really, in the entire debate.
Oh, there are people who are not going to be happy with what Mr. Dyson has to say, but it's a conversation that we believe was worth having. Let's go to that now. This time from the Institute for Advanced Studies at Princeton University. Joining me now is Freeman Dyson. Mr. Dyson, thank you for joining me.
Thank you.
Man-made climate change. Where are we at from your perspective? Is it incontrovertible science, or are we being led down a path that you are suspicious of?
Well, first of all, there is man-made climate change. I mean, it's a question how much, and is it good or bad? And there are all sorts of questions. The fact that it exists is not a question. Certainly there is some effect of humans on climate, and we have to try to find out what it is. All I would say is, first of all, we don't understand the details. It's probably much less than is generally claimed. And the most important thing is that there are huge non-climate effects of carbon dioxide which are overwhelmingly favorable, which are not taken into account. To me, that's the main issue, that the Earth is actually growing greener. This has been actually measured from satellites. The whole Earth is growing greener as a result of carbon dioxide in the atmosphere. So it's increasing agricultural yields, it's increasing the forests, it's increasing all kinds of growth in the biological world. And that's more important and more certain than the effects on climate.
Well, this is where you started your research, isn't it? In the effects of CO2 on vegetation.
Yes.
And over the years, what have you found?
Well, it's increasing just more or less as we expected. I started working on this 37 years ago, and at the time when we thought the effects were maybe about 10%, and now it's probably more like 25% after 35 years. It's essentially what we expected, carbon dioxide in the atmosphere has gone up by 40% in that time or something like that.
Yeah, up to about 400 parts per million at the moment. Just shy of that, I think.
Yes, about half of that is gone into raising vegetation. So vegetation has increased on the average by around 20%. And that's observed. And of course it's extremely important. It actually is enormously beneficial both to food production and also to the biodiversity, preservation of species and everything else that's good. So the remarkable thing is that these effects, which have nothing to do with climate, effects of carbon dioxide in the atmosphere, are so much easier to measure than the effects on climate, and so much more certain.
Well, I know that in a greenhouse where there is, industrial growing of plants for food production, the carbon dioxide parts per million is up around 1,200 parts per million. We know that it works in an actual greenhouse, but there was a considerable amount of concern as to whether or not that would actually translate into the atmosphere globally. And you're saying that the evidence is in that the benefit exists in the world at large as well.
Yes, on the average. I mean, of course, it's not true everywhere. And you can find cases where it doesn't work and cases where it does work. If you look at the details, it depends on what other nutrients are available. Of course, if the growth of plants is limited by not having enough nitrogen, then giving it more carbon won't help. And so most of the time there is enough nitrogen and giving it more carbon does help. So it's understandable that the effects vary from place to place.
You're also on record as saying that we will be able to genetically re-engineer trees to help absorb any excess amount of carbon that's in the environment. And I was reading recently about precision genetic engineering so that we can splice right into the gene and say, this is the particular component. Do you see this being like an alternative if we get to the point where we go, the level of CO2 in the atmosphere is something that we're uncomfortable with?
Yes, but that's in the very long run. And so I think people have to understand there are some things which are true right now, other things which will be true in 100 years, and other things which will be true in 500 years, and that makes a big difference. So what you're talking about, so genetic engineering of the plants all over the earth, I would say it probably at least 100 years from now. It certainly will be important in the long run, but it's a very long run. So one shouldn't think of that as something we're going to be doing in the next 10 years.
So if I come back to the question of CO2 in the atmosphere, we've seen about a 40% increase, I believe, over the last 130 some odd years of measurement. Is that correct?
That's accurate, yes.
But we haven't seen a 40% increase in temperature. So the rise of CO2 doesn't necessarily correlate to temperature change. Do you understand why all of a sudden then there is such concern about CO2 increases and what it's going to do to global temperatures?
Well, I don't try to impute motives to people. I mean, I disagree with people very strongly, but I don't say that they're evil because they disagree with me. So I'm not talking about, I think I don't want to analyze other people's motives. There certainly is an enormous religion in which there are lots of true believers who think that climate change is evil and that we're going to run into big catastrophes if we don't do something drastic. And that's a sort of a belief system which exists. I don't understand it, and I don't pretend to understand their motives.
But so much of that belief is predicated upon models that are represented, computer models that take data from weather stations around the world, and they say that this modeling demonstrates that this projection is going to work.
This, of course, I have always been fighting against, the idea that the models actually are good predictors. And my friend Yuichiro Minabe, he's a Japanese climate expert who lives here in Princeton, and he was actually the first person who ever did climate models with increased carbon dioxide just to see what it would do. And he found the warming, and it was less than is now fashionable, but anyway, there was some warming.
Is this the modeling that goes back to the late 60s?
Yes.
Yes, okay, I was reading about that.
So anyway, Manabe always said, and still he says, that these climate models are excellent tools for understanding climate, but they're very bad tools for predicting climate. And the reason is simple, that they are models which have only a few of the factors in them that may be important. So you can vary one thing at a time, so you can it helps to understand if you vary one thing at a time and see what happens, in particularly carbon dioxide. But there's a whole lot of things they leave out. And that's why they're no good for prediction. That the real world is far more complicated than the models.
And that is the challenge, isn't it?
Well, I don't say it's a challenge. I don't think any of these models can ever be really predictive.
Because climate is too complex?
Yes.
And there's too many factors at work?
Yes, and you just cannot model everything. It's way, way out of sight.
I have interviewed other scientists about climate, and I've asked them what the effect of the sun is. And they said, well, the sun has a convenient excuse. Its temperature hasn't changed. Is that true?
It's true the sun's temperature doesn't change, but its activity does change. Its activity, meaning sunspots and magnetic storms, they changed with the 11-year cycle very strongly. And we see an effect on climate. There's a young man here, in fact, called Nir Shaviv, an Israeli, who has actually studied this. He actually finds a very direct effect of this solar cycle, the sunspot cycle, on the climate. So it is important. It has nothing to do with the temperature of the sun.
It has more to do with the radiation that makes its way into the Earth's atmosphere.
Yes. It's mostly the cosmic rays, the high energy radiation. It doesn't have anything to do with the actual temperature of the sun.
And it's that ability of that energy to be able to penetrate Earth's atmosphere and warm the atmosphere that we live in.
Well, it's a complicated situation. I mean, Shaviv has studied the evidence, and the evidence is clear that this activity of the sun is having an effect. And of course, there was a big additional piece of evidence, which was the Little Ice Age, which happened in the 17th century, which also coincided with the time when the sun went to sleep for about 70 years. There was a thing called the Maunder minimum, when the sunspots just didn't happen. And at the same time, there was a very cold climate in Europe. So that's fairly strong evidence of correlation. But there's much more direct evidence now from modern observations, so that the correlation is certainly there. Exactly how the activity of the sun influences the climate is not completely clear. It has something to do with cosmic rays, but it's not direct heating of the atmosphere. It's probably an effect on clouds, but we don't know for sure.
What led me on my path to try and understand where the truth was, I watched Al Gore's movie, An Inconvenient Truth.
Yes.
And in that movie, he says, when you take water vapor out of the equation, CO2 makes up about 30% of the Earth's greenhouse gases.
That's
and
true.
so I decided yeah, it is true, isn't it? Because I started to look at that statement and I went, okay, well, how much does and that led me to ask, how much does water vapor, like what role is it? And back came this astounding number of 90%.
Yes.
And I went, well, how can you take water vapor out of the equation?
You can't.
And
I mean, it's all right if you want to talk about Mars.
because there is no water vapor.
Right.
How did we get to focus on CO2 as being this tipping point, the culprit?
Because it's something we do ourselves, and that's what makes it special. It is human activity. The fact is that CO2 is so beneficial in other ways. It would be crazy to try to reduce it.
I have been reading recently, I have tried to read the IPCC report on,
Yes.
On climate change, and I can't do it. It's beyond my ability to comprehend what it's about.
Yes.
There are so many other things that you have to understand. But one thing that struck me is that there is recognition in the report that there are adjustments made on temperature reportings from a variety of different stations around the world. Are you aware of this?
Yes.
Why do they do that?
Well, because the measuring temperature is a difficult thing. It is there are all sorts of local effects. I mean, the original measurements of carbon dioxide by Keeling were done at the top of the mountain in Hawaii,
Right.
Mauna Kea, to get away from human influences. That's where he measured it, and that was a very good move. That's why the measurements are actually very reliable.
Because they continue to monitor from there.
Yes, and
Yeah.
that's the way to do it. But the trouble is, if you want to measure the average temperature of the Earth, which is a very poorly defined thing anyway, you have to have lots of measuring stations, and the local influences are very strong. So they try to correct for local influences. If somebody builds a building nearby, it changes the temperature, and all kinds of vegetation, of course, also can change. So there's every reason for not trusting those measurements.
Is science in the business of predicting things, or is it in the business of observing, recording, measuring, telling us what we know at this point, and then leading us to the next stage of discovery?
Well, it does all of those things. I mean, we've done pretty well with predicting the weather up to a week. I mean, it's remarkable how good the
Yeah.
weather forecasting is. It has really improved enormously as a result of computer models. Up to about 5 days, those things really work.
Mm-hmm.
What they don't do is predict what's going to happen 10 years from now, or even
Or 2 weeks from now.
even next year. Yes.
Yeah.
So it's an art as much as a science, but it's improving as time goes on.
How did Benjamin Franklin, through the almanac, Farmer's Almanac, get so good at predicting weather then?
Well, of course, there are always people who can do it better, and if you're out in the open air, it does help. And
So as you look forward, I think that one of the challenges for all of us, no matter where we are in life right now, to look 100 years out, we won't be there to see what the result was.
exactly.
And so how do we know?
Well, some things you can be pretty sure of, and the fact is that carbon dioxide will increase. We will continue to burn oil and coal, and probably it does us good. The Earth will get greener as a result.
What do you say to people who want to have the same level of optimism that you do about the future, but they're afraid to go against the common or the current embracing of global warming and potential catastrophe? How do you give to viewers and the future this sense of optimism about our world that you have?
I think that if you talk to Chinese and Indians and people from Asia generally, they don't feel pessimistic at all. I mean, generally speaking, those countries in particular, things have improved so much in the last 50 years that they see continued improvement. So that this sort of mood of doom and gloom is, I would say, only particularly in the academic communities, and particularly in the Western societies, So, I don't think it's at all universal. It happens that the media have gone along with it, but I think that the general public has a lot more common sense.
I noticed that you also have Cool It on the table here
Yes.
in anticipation of our conversation.
Yes.
Why did you bring out this book?
Well, I think it's the best general summary I've seen in a way. I mean, he's an economist, not a scientist, but I think he's very sound.
Mm-hmm.
And it certainly makes a pretty good case on economic grounds.
Now, he's been attacked, of course, as well.
Oh, of course.
And Dr. Willie Soon just recently has been vilified.
Yes. No, I think the fact is that you ought to enjoy being in the minority, and that's the way I feel. Of course, I'm lucky because I'm retired. I don't have to fear losing my job.
Is any science incontrovertible? Because you get people, there is a fellow in Vancouver who is a well-respected lover of nature, and he has been explaining nature to Canadians for decades now, who is at the point where he says, if you don't believe in man-made climate change, then you should go to jail.
I mean, literally speaking, it's true. I mean, man-made climate change certainly is real.
Mm-hmm.
There's no doubt it's real, and just a question is how much and whether it's good or bad. And those are quite separate questions.
And from your perspective?
I would say it's on the whole good, and also it's not as large an effect as most people imagine.
And all in all, you remain optimistic about our future.
Absolutely. I mean, because the reason for that is I grew up in the 1930s, and everything was so much worse then. So that's, I think, the primary reason why I'm an optimist. And I mean, we never expected to survive.
At all?
In the 30s, yeah. I mean, we saw World War II coming and Hitler, and we knew about biological weapons. We expected to have anthrax bombs, and everything I look at as improved compared with the 1930s. So it's a question where you start.
Well, thank you very much for taking the time to do this.
Thank you.
I appreciate it very much.